Good evening. We will start exactly at 9:05. I can see people are joining in. 40 of them are here. Let's wait for 2 3 more minutes. Let everyone come in and then we will get started. Yes, good evening. Good evening. Good evening, Nargis. Good evening, everyone. We are starting in 2 minutes. Yes. Hello, everyone. Hi, Venkatesh. Okay, we'll just begin in 2 minutes. Okay, let me share my screen. This. Good evening, everyone. Welcome to the class. Today we have to learn divisibility rules, remainders, and modulo operator. All of these things quite important. And before I dive into that, of course, the next important thing over here is discussion on the yesterday's thing, right? What all we have done yesterday, we will just have a quick revision on those things. So I shared my screen. Number systems, yes, that's correct. Yes. Quickly revising whatever we did yesterday. Basics was okay. Zero significance. Whole number goes from 0, 1 to infinity. Natural numbers start from 1, 2, 3, 4. Then yes. So integers 0, and on the negative side -1, -2. On the positive side 1, 2, 3. Dot dot dot. Fraction is anything which can be expressed in the form of p upon q. Rational number is p upon q, q not equal to 0. Then rational numbers include integers and fractions. Then we took a square and we tried to find out the diagonal using Pythagoras, and this was giving me a value which was going on infinitely being divisible. Now that is not rational. We call it as irrational. Root of 2, pi, all of these are irrational values. Then we are just going to have the revision in 2 minutes, sir, not more than that. So don't ask any questions related to yesterday's class if you were not present in the class. Okay, you will have to watch the recordings in that case. Real numbers include rational and irrational. Complex is consisting of real and imaginary together. Then odd number, even number. Numbers which when divided by 2 give the remainder as 0 are even, and when divided by 2 give the remainder as 1 are odd. We proved that. Prime number, number which is divisible by 1 and itself is a prime number. Anything other than prime is a composite number. One is neither prime nor composite. Then fractions. Proper fraction, numerator should be less than denominator. You can see these examples. Improper, numerator can be greater than or equal to denominator. Mixed fractions, 2 into 1 by 3. How do you solve for it? 3 into 2 plus 1. Then coprime, coprimes are the ones like if I say 21 and 22 are coprimes because they have no common factor other than 1. You see the factors of 21 are this, 22 are this. Only one is common. So they are coprimes. They are also called as relatively prime or mutually prime. Today you remind me, you have a break in between, right? So just remind me after an hour. I will give you an official break. Twin primes, a pair of prime numbers that differ by 2, right? 3 and 5. Both are prime, differing by 2. 5 and 7. Greatest common factor. How do you do that? Quite easy. Highest number that divides exactly two or more numbers. So if I want to find GCF of 12 and 16, I find factors of 12, factors of 16. Found? Then which is the highest factor? 4 here, 4 here. Yes, so 4 is the highest. Right? 1, 2 are also there, but 4 is greater than that. Then LCM, smallest positive number that is a multiple of 2 or more numbers. So LCM of 3 and 5. Write down the table of 3, write down the table of 5. Which is the number which comes common at the very first? 3 is common? No. 6 is common? No. 5 is common? 9 is common? 10 is common? 12 is common? No, 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 no. 15 is the first number which is common. Least common multiple. Then number system, the one that we use is decimal number system. You remember whenever you have a number to the left of the dot, if it's decimal, it is formed using any 10 digits going from 0 to 9, any of these digits. How do you calculate the value? To the left of the dot, this number will be multiplied by 10 raised to 0, 10 raised to 1, so on. To the right, 10 raised to minus 1, 10 raised to minus 2. And we see the calculation. Same happened over here as well. Then binary to the base 2, these are the only two digits. So obviously it is not 10 raised to 2 raised to 0, 2 raised to 1, 2 raised to 2. And that's how we calculate it. I am expecting that you all have revised it. Huh? Another way to do it step by step is keep on continuously dividing by 2 and keep a track of remainders. The one that you get at the last is the MSB. At the first, what you get is LSB. Write down everything from MSB to LSB, and this is the conversion. Then octal, same way to the base 8, and the digits are only 0, 1, 2, 3, 4, 5, 6, 7. Then you can see this basic problem. Keep on dividing by 8. Whatever you get, bottom to top, MSD to LSD. Hexadecimal digits are what? 0, 1, 2, 3 up to 9. Then 10 to 15 is also there, but it is coded from A to F. You can see 10, 11, 12. How do you divide it? How do you get it? Keep on dividing by 16. Same process, right? That's the best part of it. So 992 to the base 16. This is not 922. No, it is to the base 16. Yes, this is 2338. Then after that, we have, you ask me, right, what if it is on the right side? So you keep on multiplying by 16, whatever are the results, anything before dot you record it. 1, 15, 3, 11, 6, 4, and this will go on for infinite times. You can stop up to whatever precision you want. And then these remaining parts after the dot, 0.952, you take it down, again multiply by 16. 0.232, take it down, multiply by 16. And whatever digits you recorded, write down the hex equivalent of that. And this will go from top to bottom because it is to the right of the dot. So it will go from MSD, which will be at the top, to LSD at the bottom. End of the story. Right? That's what we discussed yesterday. Now, okay, we solved it na yesterday. Same thing, right? We solved it yesterday, and in our live classes, we will not be solving examples once again. So here, who asked this? Tabu, right? A to F. Siri. Oh, your name is Siri. Okay. So octal equivalent, right? To the left side of this number. The same way we have already solved it now. To the left side of this number, you are going to. This is okay. This is binary. I get it. I get it. Now I understand why are you asking this question. Right? Very good. So you will not be able to convert this directly. You will have to convert from binary to decimal and then decimal to octal. Okay. Yes. Okay, let's do a problem for this, right? I'll take a simple one. I'll not take the exact quiz one. You solve it. I will not solve it, but I will give you an idea on how you have to do it. Okay. Is your name really Siri? I'm sure it is not. Oh, it's Siri? Apple stole it from you or what? I thought it's quite unique. Then I say, what was this number? You have to convert binary to octal. Okay. Why binary? I will take it to hexadecimal and then I'll convert it to octal. Right? I'll take it from hexadecimal and I'll convert it to octal. Just for a change. Or chalo, let me do it your example only so that you are actually getting your problem solved. So here, lecture 2. Okay. So we are having binary to octal. Let's say the example is 0 1 1 0 0 1. This is to the base 2. You will have to find out the number to the base 8. That is going to be very simple. Now, what you do in this case, the easiest way that you can do is 0 1 1 0 0 1. You are going to do groupings in digits of 3. You are going to do groupings in digits of 3, right? So you have to group in digits of 3. Why? Because in octal number system, how many digits are there? 8, right? 0 1 2 3 4 5 6 7. 2 raised to 3 equal to 8. That's how 8 numbers are there. So therefore, you have to group it in digits of 3. So this is the first group. Luckily, this is the second group. Now, what are you going to do? This is binary. You have to convert it to equivalent octal. Now, what is this number in octal is what you have to figure out. So, what is this number in octal? So, if I have to convert 0 0 1 to octal, octal will be 0 0 1. This is multiplied by 8 raised to 0, 8 raised to 1, 8 raised to 2. So, it is like 0 into 8 square plus 0 into 8 raised to 1 plus 1 into 8 raised to 0, which is 1. Okay, so I got the octal equivalent of that, and that turns out to be 1. In the same way, if I have a number like 0 1 1 and I have to find the octal equivalent of that, how am I going to find it out? So I will have to multiply it again. You guys? Oh, yes. 31 is the answer. That's correct. So okay, I'll do it in a very simple way then. I will say let's skip it. We'll make it very simple for you. More easy, more easy than this is what I have grouped it. Now, what is the binary equivalent of this? Binary, you remember, it is given by the form 8421, right? How is this? This is basically 2 raised to 0 is 1, 2 raised to 1, 2 raised to 2, 2 raised to 3. What is what is 0 0 1? It is only considering this number, that is 1. What is 0 1 1? 0 1 1. 2 and 1 is added, that is 3. Therefore, this is 3 and this is 1. Therefore, I say 0 1 1 0 0 1 to the base 2 is equal to 31 to the base 8. Okay, now what if I have a number like this, right? Second part, as I told you, I will not solve it for you. So you have to solve it. If I say 0.110101 to the base 2 is what to the base 8. Again, I'll do the same groupings. 0.110101. Group, group. Now what is this? 101, right? 101. What is 101? 1 and 1. 4 plus 1, 5. And this is 110. What is 110? 4 plus 2, 6. This is 5. This is 6. Oh, so this is 6 and this is 5. And then, therefore, I say 0.110101 to the base 2 is 0.65 to the base 8. Yes, Mr. Siri. Is that clear? Okay, now I want everyone to answer. Initially, okay, uh, I'll explain it once again and then I'll take your point. Okay, look over here. The first example I have taken where there is no point for simplicity, where I say if I have this, you group it into three because it's octal. Group of three. What is this number? This is 001. 001 is 1. So this is converted as 1. 011 is coded as 3. This is what is the answer. So it became 31. Here when you group it into 3, so 101, it is coded as 5. And 110 is coded as 6. So the number is 0.65 to the base 8. And how you convert it to binary is quite obvious, right? Everyone knows it from our yesterday's class. Simple enough to understand. Yes. For octal, yes, 3. Because 2 raised to 3 is 8, Arun. Because 2 raised to 3 is 8, you have to group it into 3. If you are doing it for hexadecimal, then you have to group it into 4. Because 2 raised to 4 is 16. Okay. How to group this for octal? Into 3, na? So if I have, I'll do it here only, 0.0101. Group of 3, and this will be group of 3. That's how you do it. Simple. And if this is 1001, group of 3, group of 3, this will be the group of 3. You get it? So I added these digits. Your voice, it's killing, na? Thank you very much, Karthik. Inside binary number 3, count U, and out size octal 1. Okay, clear, right? Yes, perfect. Chalo, then let's move on with our today's agenda. Thumbs up. All good. Let's proceed ahead. Super awesome. Perfect. Thank you very much. Chalo, let's go ahead. Today we have to start with divisibility rules. School में पढ़ा था. We studied it during school. Okay. So what is exactly the divisibility rule that we study? Number 1. If we have number before and after the dot, how to do? I didn't get your question, Siri. Can you please raise your hand? And just like every Siri speaks, will you also speak? Yes.
Hello, sir.
Yes, Siri.
The example has like 0.1010 like that.
Your voice is breaking. Can you please repeat it?
Sir, in your example, I am audible.
Ha. In my example, let me go to my example. Which one? First one or second one?
Here. Yeah,
First.
here. 0.110 like this.
Okay.
Second one.
Okay.
So here is the number point after right side 110101 like that.
Ha.
We separated three, each one three,
Ha.
right?
Groups of three.
Suppose the right side of the number there is zero, right?
Tell me the number. Any number. You tell me.
1101 0 0.
Hmm.
Then how can we do it?
Same thing, na? Group of three and group of three. So what is
I am
one?
not saying like that.
You only
Uh,
said like this, na? You gave me the number. I didn't write it.
no, sir. The number is 0.110101, right? If
One.
we can take like 110.110101
Okay.
instead of zero, I am saying some number, then point, then some number.
Siri, Siri, don't confuse me. You tell me the number, I will work on that. Tell me any number which you have in your mind.
Okay, I'm writing.
You tell me here, na? I'll write it.
I have faced this in quiz, so I'm asking.
How you tell me the number, na? How will I come to know?
I have texted.
Huh. So what is the problem in this number? It is
We have seen example like 0 point something else. Instead of zero, there is like 11100101, right?
no. We have seen that example also, na? Here, see. This one is also seen 0110. Then you do grouping from left side.
But in that example, there is no like point other number.
See, I'll tell you. See, understand over here. I'll take your number. 11000101 dot 001010, right? You are going to group in three. When to the dot, right? You start from dot. To the right of dot, three is group, three is group. To the left of dot, you start from left to right now. Three, three, and this will be a group of three. But where are the numbers?
Zero, zero. That's what I'm asking. If we have the point right side any number that should be included or not.
Ha, it will be included, no? This will be included.
Okay, sir. Okay, that's what
Hmm.
I'm asking.
So basically, now if we got to solve it, then what is this going to be? 2.
Yes,
This is 1.
one,
This is 4 plus
three,
1, 5.
three.
5, na?
Okay,
5.
yeah, yeah,
This is 4. This is 1. To
one.
the base 8.
Mm.
You
Okay,
made
sir.
me
Perfect.
solve it. That is cheating.
No, no, sorry, sir.
Okay. Chalo. Then so many people have raised your hand. Is it by mistake or you want to speak? Munendra and Konda Srinivas. Who is speaking?
Hello.
Who is speaking?
Yes, sir. Srinivas Konda.
Yes, Srinivas.
Yes, sir. Actually, I came. I came to the class by late by 30 minutes.
When? when Ajay has left. Okay, I think Srinivas has left. Provide us some more questions so that we can clear out completely. Okay, I'll do one thing. I will give you some questions for practice towards the end of the class. Let us start with the today's class, and then towards the end, I will give you some additional questions. Okay, chalo. So means if we can't group into three, yes, of course. If you can't group into three, you are free to take zeros. Fully clear. Very good. Okay, guys, please be very careful when you are using the platform. I can see people are asking to be on the stage and then not speaking by self. This is wrong in the sense it is distracting me as well as distracting others in the class. Shubham, it's not specifically pointing to you, but before you also there were two, three people who did that. So you know what happens is you get that sound, ding. So I am like, is there any question? So human mind gets diverted. That's the reason. Perfect. No problem. Okay. Everyone, please make a note of that. I'm not specifically pointing out Shubham. Okay. It's for all so that we are able to maintain a good decorum in the class. Chalo, let's go ahead. Divisibility rule. I'm talking about divisibility rule for 2. What is the divisibility rule for 2? It says if its last digit is even, we say a number is divisible by 2. Example, if you have a number like 2168, since the last digit is even, it is divisible by 2. If you have a number like 121345 6, since the last digit is even, it is divisible by 2. So the last digit of the number, if it is an even number, it is divisible by 2. Straightforward. Thumbs up if it's clear. This is very simple, but I just don't expect all of a sudden I go ahead and questions regarding this. This is quite simple and straightforward. Okay, very good. Then second is divisibility by 3. So now if the sum of the digits is divisible by 3. For example, if I have a number like 123, is it divisible by 3? I will try to total 1 plus 2 plus 3. What is the answer? 3 plus 3, 6. 6 divided by 3, 2. Yes, it is divisible, right? Or I will write it in more specific way. 6 divided by 3, 3 twos are 6. Remainder comes out to be 0. So I can say that yes, 1, 2, 3 is divisible by 3 because the sum of digits is divisible by 3. Let's take one more example. 1, 2, 3, 1. Is it divisible by 3? 1 plus 2 plus 3 plus 1, which is obviously going to be 3, 4, 5, 6, 7. 3 twos are 6, remainder is 1. So you're not getting the remainder as 0. Therefore, 1, 2, 3, 1 is not divisible by 3. Right? So these all things are very simple, and you also understand it. I can clearly see in the conversation you all are able to understand it. Third, I write it. Four. Here I say if the last two digits of a number are divisible by 4, we say the number is divisible by 4. For example, let's consider the number like 2624. You consider the last two digits. Is 24 divisible by 4? 4 6 are 24. Remainder is 0. Since the remainder is 0, I say 2624 is divisible by 4. Okay, let's take one more example. 1321. So last two digits are 21. I'll take 21 divided by 4. 4 5s are 20. Remainder is 1. Therefore, I say 1321 is not divisible by 4. Right? Please observe it. Straightforward. Going ahead. Right? Thumbs up if everything is clear. You know, all of a sudden it should not backfire. That, sir, I'm not able to recollect that. Okay. So good. Good, good, good. Thank you very much. Let's go ahead. 5. I say if the last digit is either 0 or 5. If the last digit is either 0 or 5, we say it is divisible by 5. Example 216295. Last digit is 5, so it will be divisible by 5. 1234010. Last digit is 0, it will be divisible by 5. And we also know, right, it's quite obviously any number which is ending in 5 or 0 is going to be divisible by 5. Srinivas and Srinivas and Srinivas only. Which one you want me to explain? Divisibility by what? Srinivas. Divisibility will be what? Which one you want me to explain? See, you don't confuse me. What I asked you. You want me to explain divisibility by what? 5 or 4? This one or this one? Which number are you talking about? 0 to we never discussed. Srinivas, time is very precious. Please answer quickly. All of us are waiting for you. Okay, Srinath, since I'm not understanding your question, I'm going ahead. I have tried asking you 4 times what to repeat. Let's go ahead. You type the question clearly, then I will repeat that particular part for you. Number 6, right? So, what is the divisibility test for 6? Some of you already answered it, right? Yes, and you are correct. If the number is divisible by both 2 and 3, then it is divisible by 6. Example, let's take 36. Can 36 be divided by 2? Yes. 2 ones are 2, remainder is 1. 16, 2 eights are 16, remainder is 0. And can 36 be divided by 3? 3 ones are 3, remainder is 0. 6, 3 twos are 6, remainder is 0. Since both of these things are giving a remainder as 0, I say that 36 is guaranteed to be divisible by 6. You can confirm it. 6 6 are 36, right? What to say? Right? 6 6 are 36. If I consider a number, right? If I consider a number, maybe a bigger number, which is divisible by 6. For example, let's say I'm considering 78. 78. So is 78 divisible by 6 or not? How can I confirm? It has to be divisible by 2. How do you check whether a number is divisible by 2? 78 is divisible by 2 since you have even number in units place, right? 8 is there. And 7 plus 8, which is 15. And 15 when divided by 3, 3 5s are 15, remainder is 0. Therefore, 78 is divisible by 3. I applied the divisibility test. And since it is divisible by, since 78 is divisible by both 2 and 3, we conclude 78 is divisible by 6. Finish. As simple as that. Okay. Which difference even and odd number? No, we are not talking about any difference over here. Absolutely no differences. You are only considering the units place. That's it. An even number in place should be the last digit. The last digit should be even number. What we just discussed, right? The last digit should be even number. As simple as that. Clear? Same test of divisibility of 2 and 3 are applied. We didn't do anything new. Yes. Welcome. Let's go ahead. This is fifth one. I go to the sixth one where I am discussing the divisibility test by 7. Here I say it says if the last digit I say over here, if the last digit of the number is doubled. Now this is a little bit complex. Just follow it. If the last digit of the number is doubled and subtracted from the rest of the number, and this difference is divisible by 7, then we say that the number is divisible by 7. How to do that? See, let me consider an example over here. Let's say I am considering 154. Observe this example. Before you ask any questions, observe this example. 154. What did I say? If the last digit of the number is doubled. So in 154, what is the last digit? 4. Right? So double the last digit, that is 4 into 2, which is 8. Right? So if the last digit of the number is doubled, so we done that. What is the next thing? Then we have to subtract it from the remaining number. So see, this was the last digit and this is the remaining number, right? So remaining number is 50. So now what we do, we subtract 15 minus 8. What is 15 minus 8? 7. So if the last digit of the number is doubled, that is ready over here, and it is subtracted from the rest of the numbers. The rest of the number is 15. We have 15 minus 8, not 8 minus 15, 15 minus 8. Answer is 7. And if that difference, right? So 7 is the difference. Now I have to check whether the difference is divisible by 7. So I check 7 divisible by 7. Yes. So I can write it like this. I say, since the difference is divisible by 7, comma, the number 154 is divisible by 7. 154 divided by 7. And I say equal to 22. Show you again. 154 divided by 7. 22. It works. Yes. Now go through this example once and confirm me whether it is clear. I will ask you that time only you confirm, not before that. Okay, Yogesh says, I think only one question by Yogesh. What if the number is of more than 5 or 6? Yogesh, let the number be even 1000 digit. This logic will work. The number can be any digit, any number of digit. Let's consider any more example, right? So I say, let's say I consider a number more big. I say here. Okay, I'll do it here only, no, for you. No, not required. I'll write here. What is the logic over here? Is now this time I'll not write in detail. I'll write in short. 4172, right? If I say 4172, 4172 is divisible by 7. I just did it on my mobile phone. So I say last digit of the number should be double. So what is the last digit? 2. And this is the remaining. 2 will be doubled, right? So this is the double form. Then it has to be subtracted from the rest of the number. 417 minus 4, which is 413. Then you have to check whether the difference is divisible by 7. So check karo na. So 7 5s are 35. This is 63. 7 9s are 63. Remainder is 0. Why do you doubt the rules? Huh? When these rules are drafted, there is no question of doubting. Are you getting that particular part, Yogesh? Is this clear now? Yes, Sanjit said it very clearly. You consider any infinite number, it will work. This is not what Darshan has formulated. These are the divisibility rules. So मैं क्या कोई भी नहीं change कर सकता, right? You can't change it. No one can change it. As simple as that. Okay. Then this is sixth. Then I go on to seventh. So in the seventh, we are looking for the number 8. This is very simple. I say, instead of, see in 4, you are looking for the last 2 digits, right? So here in 8, if the last 3 digits, if the last 3 digits of a number are divisible by 8, then the number is divisible by 8. Yes, the last 3 digits should be divisible by 8. Then only it is divisible by 8. So if I consider a number like 4768, these are the last 3 digits. 768. Check if it is divisible by 8. 8 8s are 64, 8 9s are 72, 8 9 7 2, remainder is 4 8, 8 6 is 48, remainder is 0, and therefore 4768 is divisible by 8. Okay, I'll give you some homework over here, right? So you have to whether check if following number is divisible by 8. First is 4,77,496. Second is 4,77,448. Third is 4732. Next is 64. Now, how are you going to check for 64? Directly divide by 8. Now, if it's a big number, then this rule will be used. If the number is small, directly divide by 8. No need to ask, right? Like you do in your regular days. Same thing you do it. These divisibility rules usually help when the numbers are big. Samjhe? Is that clear? Thumbs up if it is clear. Awesome. Very good. Super. Then that was seventh one. Eighth one. Talking of the number 9. 9 is very simple. 9 is like 3 only. I say if the sum of digits is divisible by 9. So if I consider example like 4122, what will I do? What is this? 4, 5, 6, 7, 8, 9. 9. So 9 divided by 9, ha, 0. So I say therefore 4122 is divisible by 9. Let us consider a bigger number. I'll say 412965. 4 plus 1 plus 2. Tell me the total of this, yaar. Why are you not working on it? Tell me the total of this. 4 plus 1 plus 2 plus 9 plus 6 plus 5. I give you 5 seconds. What? Total of this 412965. Hmm. What happened? You are solving it? Give me a thumbs up if you are solving it. Oh, you are doing it. Okay, okay, okay. Sorry. I think I gave you too less time then. Please don't use the calculator. Huh? Dimag use karo. Brains. Use that. Do it orally. Still no answers in the chat? What? क्या कर रहे हो? Where is the answer? What is the total? Write it in the chat. Yes, write it in the chat. Unnam, Arun, Avnish. I better hope that's a
Yes,
question.
answer. You will
Yes,
answer.
pardon?
Yeah, now you can see the chat.
Why like that?
Yes, sir.
Uh,
Actually, you didn't scroll down, sir. That's why you can't unable to see the chat, sir.
Sir, if you scroll up, you can see a blue color down arrow box corner. You have
Ah,
to
Yes,
click
sir.
there.
Yes, sir. That's why I'm just asking to unmute me, sir.
oh, acha, okay. So many people answered, and that's why it was not. I get it.
Yes.
Yes, sir. Yes, sir.
Okay, okay, okay. Thank you very much. Maybe I'm a little bit not familiar with the platform. I will make a note of this. Auto scroll should have been enabled. Okay, 27, and you solved it as well. Very good. 27 and 27 divided by 9, 9 threes, 27, remainder 0, and therefore 412,965 is divisible by 9. Good. Now after that, what all are we going to do after that? We are going to do for 10, 11, 12, and post that we have to do a little bit of number systems. I'll tell you. So as we all decided, we will be going on a short break of 10 minutes and then we will resume. Yes, yes, yes. I got it. I got it. Thank you very much, Uttam. Unnam. I'm sorry. Unnam. Got to focus here. Okay. So here it is. This is 10:03 on the clock, right? You guys are going to refer to this time, right? My time. We'll go for exact 10 minutes break. For 10:13 we come back. Okay, 10:13. We'll follow this clock. Okay, we'll come back at 10:13. Okay, Kishan. Yes, that's correct. Yes. Thank you guys. See you after the break. Okay, so going ahead, please expand the 7 number point after break. Okay, Akshay, are you there? Yes. Not Akshay Umredkar. The one who asked the question was Akshay. Is Akshay Virupaksh? Are you there, Akshay Virupaksh? Ah, yes, you answered it. I'm sorry, I didn't see it. Okay, let's go ahead. Point number 7, you asked it, right? Going back. This is point number 7, right? Divisibility test by 8. How do you know whether a number is divisible by 8? You have to see whether the last three digits are divisible by 8. So in this 4, 7, 6, 8. 7, 6, 8 are the last three digits divided by 8. Is the remainder coming out to be 0? Yes. Then it is divisible. Simple. Right? Last three digits should be divisible by 8. And if it is getting divided, it's divisible. Okay. Perfect. Very good. Then 10 is stupid. 10 is very stupid. If number ends with 0, it is divisible by 10. 0, 10, 20, any number. Okay, if it is ending in 0, it is divisible by 10. As simple as that. Then the next is divisibility by 11. Yes, welcome Akshay. For divisibility by 11, the idea is if the difference, okay, this is again a little bit odd, if the difference of the alternating sum of digits, the alternating sum of digits is a multiple of 11. Now, how do I say that? See, let's take an example to understand this. So, if I have a number like 3, 7, 8, 4, what all are the alternating sum of digits? Here, oh no, sorry, not 3, 7, 8, 4. If I'm considering more bigger number, let's say, let's consider, okay, we can start with 3784 also, and then I'll take a bigger number for you. So if I'm taking a number like 3784, so over here, how many number of digits are there? The number of digits are 4. 1, 2, 3, 4. 4 digits are there, right? So what I have to do, I am going to find out the alternating sum of digits. And I'm going to see whether it's a multiple of 11. So over here, what is going to be the first digit? Difference of alternating sum of digits. So here, you all are here. Let me just check. Very good. Just expecting the same thing. Just expecting the same thing. Very good. 3 plus 8, 11. 7 plus 4, 11. 3 plus 8, 11. 7 plus 4, 11. So nice. So let us see. So this is one alternating pair. You start from the leftmost side. You start from leftmost side. So if I say what is alternating pair 1, it is 3 and 8. Alternating pair 2, it is 7 and 4. Now 3 plus 8, 11. 7 plus 4, 11. What do they say? Alternating sum is what I have found out, right? Alternating sum of digits. This is first alternating sum. This is the second alternating sum. And what I need to see whether it's a multiple of 11, right? So difference. What is the difference of this? 11 minus 11, 0. Is it a multiple of 11? Yes. 11 into 0 is 0. So it's a multiple of 11. And therefore I say 3784 can be divided by 11. Let's check it out. So here 3784 divided by 11. 344 is the answer. Okay. If you do it from the right, then the answer would be the same. Let's consider one more example. 82907. Let's try alternating this. So this is basically 8 plus 9 plus 7. So 9, 9, 18. So 9, 18, 17. 17 plus 7, 24. And this is 2 plus 0, which is 2. 24 minus 2 is 22. You check whether 22 is in the table of 11. Yes, of course, 22 is in the table of 11. 11 to the 22. And therefore, you say this number is also divisible by 11. And this number is also divisible by 11. Okay. Let me give you one more example and you tell me whether it is divisible or not. So the number is 9647. 9647. Don't try it on calculator. Huh? Okay, send me the calculation. What minus what? 13 minus 13. Okay. 13 minus 13. Very good. So anyone having any questions? Good, good. Very good. 13 minus 13. All good. Very nice. Very nice. So now this is your homework. Then the last one. How many divisibility tests should we ideally know? Enough. I mean, I only remember a few of them, and that too directly, right? So I'm considering a number like 12 now. Here, I say if number is divisible by both 3 and 4, then it is divisible by 12. Absolutely nothing as such to be checked over here, right? It is quite straightforward to figure this out. Right? If both of these are working in this way, then it's fine. Now I'll go ahead. There I say Sir SK enter. I don't know any question. I don't use calculate. Shubham accepting it. Yes, Shubham. Shubham. No, actually, Kishan, the problem is what SK Enterprise says. Most of the questions I don't understand it because there is a lot of grammatical issue over there. I really find it very difficult to understand what you are typing. So somehow I try to make sense of it, but not 100%. And because of that, misunderstanding happens. Okay, let's go ahead. SK, if you know Hindi, you can type in Hindi. I am okay with that. You can explain him in Hindi, but मुझे question तो समझे तब हिंदी में explain करूँ ना. SK, if you know Hindi, you type it in Hindi. I mean, your language be English, but you type Hindi. जैसे कि मेरा नाम SK Enterprise है, right? Something like that. हाँ, हम क्वेश्चन समझ रहे हैं. वेरी नाइस. ऐसा कुछ लिखो, मजा आ जाएगा. लेट्स गो अहेड. और आंसर भी yes. So the next one which I want to explain you all is you need to understand the difference between division and remainder, right? You need to understand. मेरा नाम SK Enterprise है. वो एंटरप्राइज क्यों है मुझे वही नहीं समझ रहा है. अपना सच्चा वाला नाम क्या है वही नहीं पता मुझे. Anyways, let's go ahead. So now I want to talk about few things related to remainder, right? This is important for everyone. For example, if I have a number like 13, we say 13 divided by 6 is 2. And how do you get it? I say 13 divided by 6, 6 2s are 12. This is going to be 1. This is what you call as quotient. This is what you call as remainder. How do you write it? This is how you write it. 13 divided by 6 is 2. 13 modulo 6 is 1. So basically, division gives quotient Modulo gives remainder. Make a note of this. Division gives quotient. Modulo gives remainder. Now, there are few things around this which could be confusing, and therefore I am teaching you. Then, how could okay? How could align? Very nice, Venkatesh. कंपनी का छोटा नेम है एसके एंटरप्राइज सो योर नेम इज राहुल राज नाइस राहुल नाम तो सुना ही होगा हमने तो नाम भी सुना है और एसके एंटरप्राइज भी सुना है वी हैव हर्ड बोथ ईश्वर से ही इज अ रोबोट ब्रो robot even don't remind me of that movie right I just love it eagerly waiting for 3.0 as well मेरे मॉम के नेम पे भी पार स्टोर है अब ये पार क्या है PAR क्या होता है वेंकटेश यू आर नीलिंग इट पार्ट स्टोर कौन सा पार्ट स्टोर किसका पार्ट किडनी बेचते हो लिवर गुर्दा व्हाट डू यू सेल placed every everything oh it's a computer accessory store guys you require a mouse you require a keyboard you require any accessory for cleaning we have Rahul Raj with us Rahul you can start an e-commerce store here only Rahul will give discounts because we all are his close friends now yes Rahul दोगे ना discount we will give you business in bulk 70 mouses free Amazon seller central store upload all products okay 100% discount cool चलो टाइम लेट्स गेट बैक टू द टैक्स सर आपने हिंदी में बात किया तो बोला सब खुल के बोल रहे हैं हाँ बट द थिंग इज एवरीवन डजंट अंडरस्टैंड हिंदी ना सो आई कैन नॉट स्पीक कंटिन्यूअसली इन हिंदी else usually I have seen people from South India and to the eastern side of India. They are not aware of Hindi very nicely. So they face problems over here. Okay, so let's go ahead. We have agenda to be covered. You're in the eastern, sir. Where? You know, eastern in the sense Assam, Mizoram, Myanmar, that side. उत्तर भारत तो है ही हिंदी उत्तर भारत हिंदी है you are from Assam right okay you know most of the car washers which are there in my building those all boys are from Assam only and they also know Hindi that's correct I know Hindi but can't speak fluent Hindi civil engineer PCR okay चलो बॉलीवुड का असर है सर यस दैट्स करेक्ट बॉलीवुड तो डूबने वाला है जाने दो टॉलीवुड का असर होना चाहिए अभी एनीवेज फॉर योर काइंड इंफॉर्मेशन 0/3 is 0 0/3 is 0 wait a minute I'll write it specifically I'll solve it like this 0 divided by 3 3 zeros are 0 so this is quotient and this is remainder so you understand this if I have 1 divided by 3 3 zeros are 0 remainder 1 if I have 2 divided by 3 3 zeros are 0 remainder 2 if I have 3 divided by 3 3 ones 3 remainder 0 If I have 4 divided by 3, 3 ones 3, remainder 1. If I have 5 divided by 3, keep on observing, keep on observing. 3 ones 3, remainder 2. If I have 6 divided by 3, 3 to 6, remainder 0. So what do you see? Keep on observing the remainders. I would say just keep on observing the remainders. 0, 1, 2, 0, 1, 2. Do you or are you convinced that the remainders, right? Your numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are you convinced that the remainders are always going to repeat in the cycle of 0, 1, 2? Convinced with that? Give me a thumbs up if you're convinced that the numbers are going to repeat in the cycle of 0, 1, 2. Right? Yes. Numbers are going to repeat in the cycle of 0, 1, 2. Now, some people find it difficult, and we have something which is called as a clock method, right? I never use it, but some people find it difficult, and for them specifically, we have this clock method to identify remainder. Now, before that, I would like to say that if you are dividing by 3, right? If I am dividing by 3, then these all are the remainders. So if you are dividing by 3, the remainder is 0, 1, 2. In the same way, if you are dividing by 7, then the remainder will be 0, 1, 2, 3, 4, 5, 6. Right? If it is 3, it goes from 0 to 3 minus 1. If it is 7, it goes from 0 to 7 minus 1. If it is 9, it goes from 0 to 9 minus 1. If it is 2, it goes from 0 to 1, and so on and so forth. Are you convinced with this? Are you convinced with this? How the remainders are? Thumbs up de do jaldi. Sanjit, you forgot 0. Sanjit, you forgot 0. Sanjit Arya, are you understanding? If you are dividing it by 4, then if the number itself is 4, then 4 divided by 4, remainder is 0. Samjhe na Sanjit? Yes. Good. So now that was a very important thing. Correct. So I can say that in very simple words, if you are finding the number divided by n, then it should go from 0, 1, 2 up to n minus 1. Simple, no? Generalized. Okay, but I was talking about the clock method. What is this clock method? Look at this, clock method, everyone. No problem, Sanjit, that's okay. If I want to find out 8 mod 4, one thing I know that if I am dividing by 4, now you all are talented enough to know that the possible remainders are 0, 1, 2, and 3. And if I have 8 divided by 4, we can clearly see, we can say over here 4 2's 8, remainder is 0. Now what I do? Look at this. This is one way, and I know that yes, the remainder is 0. I got it. So basically, therefore, I conclude that 8 modulo 4 is equal to 0. Convince. Where is the clock method? I'm starting it now. Okay, look at this. I mean, see, if you like it, you use it, or you can use this regular way as well. So what I do is, I want to calculate, I'll write it here only. I want to calculate 8 modulo 4, right? I want to figure out what is the answer to this. I create a clock around this, created. And what all are the possible remainders? I start writing. So the possible remainder is 0. You can write anywhere. It's like a clock. So I'm preferring to write it from here. Then I write 1. Then I write 2. And then I write 3. You can write it anywhere. I'm just evenly distributing it. Now you start with it. What are you starting? Here, what are you going to do? The number is 8, right? The number is 8. You start from 0. You start counting from 0 and you are going to go up to 8. I'll tell you what. You have the number as 8. So I'm going to start counting from 0, 1, 2, 3, 4, 5, 6, 7, 8. I'll go from 0 to 8. Let's see how. 0 to 1, right? Then 1 to 2, then 2 to 3, 3 to 4. I'm not saying 0. I'm talking about these numbers, pink numbers. 0, 1, 2, 3, 4, 5. This was 5, right? Then this is 6, 7, 8. Right? I counted it. I'll write this for you, right? So this was 0, 1, 2, 3, 4, 5, 6, 7, 8. So I counted 8, right? I just went from 0 to 8. Now this dot is ending where? Where 0 is there. And therefore the answer is 0. Oh, yes, you got it right. It is ending that way. Therefore, let me prove it to you with the help of one more example. Okay. Let me first of all come to ask you, how many of you understood it? Give me a thumbs up. Very good. So, okay, I'll explain it once again. Let's say, okay, everyone, I once again repeat, no one is going to ask you this method in real life. It is just like you either use this method or this. If you ask me, I prefer this. This is easy. What is this? Goal, 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 ghumo. Unnecessary moving round and round. But anyways, if I have to find out it, no, let's change it. If I want to find out uh, 9 modulo 3 equal to question mark. So if I have 3 and if I'm dividing by 3, what all are the possible remainders? If I'm dividing it by 3, what all are the possible remainders? Correct. That's correct. 0, 1, 2. So 0, 1, 2. Right? So how am I going to write my clock? 9 modulo 3. Where can I write 0? Wherever you want. I prefer to write it over here. Now I have to write only 3 numbers. So I need not write it at 4 edges. Let's say 1 and 2. Right? So whatever are the remainders which are getting generated, we'll write it over here. And what is the number? 9, right? So I'll write it once again in pink ink. So for generating the number 9, I will start counting from 9, right? So let's get started with it. Using the white ink. I always start from here. 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. Where did my outer circle end? At 0 now. So the output of this is 0. Easiest way, right? Very good. Now, understood, right? I'll explain it once again with respect to a different example. And this is going to be different. Let's say if I ask you what is going to be minus 5 modulo 3 equal to. The idea is to do the same thing. So I will look at uh, when I divide by 3, my remainders are 0, 1 and 2. I want to find out. Look at this. This is different. This is different because the number is not positive. The number is not positive and therefore this is different. So what all are the remainders I am writing? So this is 0. This is 1. This is 2. Now, if it was a positive number, you might have noted that we were going this, right? Clockwise. We were going clockwise. But now the number is negative. If the number is negative, I will be going anti-clockwise. I'm again going to go that way only. So if you recall, the number is minus 5, 0, minus 1, minus 2, minus 3, minus 4, minus 5. Let's start. Start from here. 1, right? Minus 1. 0 to minus 1, minus 1 to minus 2, minus 2 to minus 3, minus 3 to minus 4, minus 4 to minus 5. So what is the answer? 1. Yes. Got the answer. Therefore, minus 5 modulo 3 is equal to 1. As simple as that. So it helps a lot over here. Now, if anyone has any question, yes, this is right. For negative number, it is really working like magic. Amazing tricks, right? If you have any questions, feel free to write it in the chat. Before I start with two problems, clock problems, right? I'm going to start talking about clock problems. If you have any questions, feel free to ask me in the chat. I did not understood. Which one? The last example? Could you please take one more example for negative? Okay, fair enough. So we'll do one thing. I will add this. Okay. So let's take one more example for negative. If I want to understand what is minus 7 modulo 5 equal to, whenever I'm dividing by 5, in that case, solve the question without anti-clockwise. Tell MR how one came. I get it. I get it. And could you take one more example? Okay. Over here, first we'll solve it this way. So here, the idea is, what I do is reminders are what? Right, 0, 1, 2, 3, 4. I write minus 7 modulo 5. And I want to write 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Start with it. You have to go till minus 7. So how will you go? 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Start. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Answer is 2. Because it's negative number, we did go in the anti-clockwise direction. Okay. So understood. Now I will solve the same problem as Venkatesh Sharma asked without using anti-clockwise. Okay. To Rahul Raj. To Rahul Raj also it is clear. Very good. Now, the next thing is, very good. We have to understand how to solve this for negative numbers. Ideally, not required, but I'll just show it to you because you asked for it. How to calculate modulus of negative numbers. But honestly speaking, you don't require it, to be very honest. So always remember. And mm, okay, do one thing. clock around you. Correct answer. Send it. सर्दी है तब दिल का मरा 200 नंबर हो पैट्रिस में वो खाइए. Okay, what we will do is listen to me. Hmm, what I will do is I will go ahead with this problem and your problem, right? What you asked Venkatesh Sharma, we'll take it towards the end because time is less and I want to complete with the agenda first. But sir, in the previous equation, minus 5 modulo 3, you go in the clockwise, not, no, I went anti-clockwise only. I went anti-clockwise. कौन सी दुनिया में हो? It is anti-clockwise, no? Acha, you understood it. Okay, okay, great, Venkatesh. So, kal is okay. Gitanjali, is that clear? Gitanjali, 0, 1. Huh, that has to be written in clockwise only. 0, 1, 2, those things have to be written in clockwise only. Your movement has to be in the anti-clockwise. Right? Your movement will be anti-clockwise. You write the numbers in clockwise only like you write every time. In this example, it changed. Let me check 0, 1, 2, and then oh, my mistake. My mistake. That's my mistake. I should not have changed that. I should have gone that way only. My mistake. I'm so sorry for that. So I'll do one thing. I'll change it quickly. That's my mistake. You have to write it clockwise only. This is 0, 1, 2, 3, 4. So where are we ending? We are ending at 3, right? So the answer to this is 3. I'm so sorry for that. Very good observation, Gitanjali. Right? Numbers have to be written clockwise only. Only movement will be anti-clockwise. Yes. Clear now, Gitanjali? There also. Yes, there also. I mean, here, let me just check. Any here and here it's clockwise. Here it's clockwise. Here also it's clockwise. Right? So 0, 1, 2, 3. 0, 1, 2. 0, 1, 2. 0, 1, 2. 3, 4. If the number is negative, your movement, white movement is going to be anti-clockwise. Yes. Let's go ahead. Clock problems. Oh, that's already written, no? The question is, we'll solve two problems like this. A watch gains 5 minutes in 1 hour and I'll explain you the question, and was set right at 8 a.m. What time will it show at 8 p.m. on the same day? First, let me tell you what I exactly mean by the question. Here, a watch gains. Welcome everyone. So I'm sorry I committed a small mistake over there and it created a little bit confusion for you. Happy that it's clear to all of you now. So clock problems. So here we say that a watch gains 5 minutes in every 1 hour, right? So in every 1 hour, this clock gains 5 minutes. What do you exactly mean by gains? So if it is 8 a.m. right now, after 1 hour, if your watch is working perfectly, it should become 9 a.m. Right? I repeat, if it is 8 a.m. after 1 hour, it should ideally become 9 a.m. But there is a problem with this clock. If it is 8 a.m., after 1 hour, it will show 9:05 a.m. In Hindi, we say, घड़ी fast चल रही है. What do we say? घड़ी 5 मिनट fast चल रही है. You're understanding the problem with this watch? It is running 5 minutes faster. Yes. So now you understood what is the question. Now, considering these all things, we have to now figure out that the watch, right? If you look at this watch, what do we say? Watch gains 5 minutes in 1 hour, and it was set correct at 8 a.m. What will be the time at 8 p.m.? So if it starts at 8 a.m., then it is going to complete how many hours in case of a normal watch? In case of a normal watch, wow, I didn't ask it to complete, still it is doing that. In case of normal watch, it has completed 12 hours, right? It has ideally completed 12 hours. But in every hour, it is running 5 minutes extra, right? In every hour, it is running 5 minutes extra. So in 12 hours, it will be running 12 into 5, which is 60 minutes additional. So ideally, a normal clock after 12 hours should show 8 p.m. But this clock is going to show 8 p.m. plus 1 hour, which is 9 p.m. Simple. Understanding it? All right. Very good. Perfect. That's exactly what was the question about. You understood it. In the same way, I'm going to give you one thing for your homework. So we say a watch, it doesn't gain. This time I'm saying that it loses 5 seconds in 1 hour and was set right at 7 a.m. What time will it show at 2 p.m. on the same day? Right? So that is the question. What time it will show at 2 p.m. on the same day? Okay. Now after this, I said I will give you some practice questions for homework, right? So let me try to give you those things on number systems. 125, okay, whatever it is, I don't care about it at the moment. So I say over here, I'll give you ample examples to practice. Starting with the first one, decimal to binary, 20, 120. Then 0.61. Then 20.62 converted. Then I say decimal to octal. Let's say 217, 2556 converted to octal. 0.39 converted to octal. You got to multiply by 8. We have already seen that methods. 12.93 converted to octal. Then the next is octal to decimal, 746. 0.123. You have to multiply it by 8 raised to 0, 8 raised to 1, 8 raised to 2, 8 raised to minus 1, 8 raised to minus 2. Then I say decimal to hexadecimal. So so much homework that you will be tired. 2338. 0.132. I say 12.48. Then binary to octal. You remember the groups of 3, right? That's going to be 0, 1, 0, 0, 1, 0, 1, 0, 1, 0.01010, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1, 0. And then I say the last one, yes, and the last one is binary to hex, where you can take 1, 1, 0, 0, 0, 1, 1, 0. That can be taken as the first number, or you can take 1, 1, 0, 0, 1, 0, 1, 1.1110. This is binary. You have to convert it to hex. Fair enough. Enough. If I give you more, you will stop coming for the lectures. So too many examples discussed over here, and that is exactly where I will come to an end. Okay. Everything clear for the day? Any questions that you have? All good? कोई मित्र नो शेयर करेगा क्या? कोई नो नंबर शेयर करेगा क्या? Done. Clear. Very good. And और कोई और कुछ कोई सवाल? वेरी गुड. सो शुभम राज बहुत परेशान करता है शुभम. यू नेवर टॉक बट यू रेज द हैंड.
यस सर. हाय सर.
हाय.
सर मैं बोल रहा था सर, वो जो आप बाइनरी नंबर में 8431 वैसे करके जो ऊपर में दिए थे,
हम्म.
तो सर वो किस टाइप में मतलब उसको मतलब जस्टिस कर रहे हैं, मतलब वो किस टाइप में मतलब आप वो लगाएं जिसके नंबर में मतलब 011 वैसे करके जो नंबर सब दिए थे ना.
कभी कभी देखो ये वाला लेक्चर वन अपना ये वाला है यहाँ पे.
यस सर. बाइनरी बाइनरी नंबर.
स्टार्टिंग में ना.
यस सर.
ये
यस
वाला.
सर. दिस वन.
हाँ हाँ.
सर वो जो 8421 जो लिखे हैं ना,
हाँ हाँ.
वो मतलब कैसे मतलब ये कोई रूल है क्या इसको मतलब लिखने का
रूल
या?
रूल नहीं है देखो. डेसिमल नंबर टू द बेस 10 होता है.
हाँ.
बराबर है. तो अगर तुमने यहाँ पे देखा रहेगा और अगर मैं 512 नंबर की बात कर रहा हूँ तो मैंने क्या बताया, इट इज टू द बेस 10. तो मैंने इसको 10⁻0 से मल्टीप्लाई किया, इसको 10⁻1, इसको 10⁻2. इतना समझा.
यस सर.
वैसे ये वाले नंबर में देखो, इसको डॉट के लेफ्ट साइड में इसको 10⁻0, इसको 10⁻1. डॉट के राइट साइड में 10⁻1, 10⁻2. समझा.
यस सर.
ये इसलिए किया क्योंकि ये डेसिमल नंबर है एंड डेसिमल नंबर इज टू द बेस 10. अब इसके बाद जो नीचे किया है वो है बाइनरी नंबर एंड बाइनरी नंबर इज टू द बेस 2. अब 2 का बेस है मतलब इस नंबर को मैं 2⁻0 से मल्टीप्लाई करूंगा, इसको 2⁻1 से, 2⁻2, 2⁻3, 2⁻4. राइट. तो अगर 2⁻0 का वैल्यू क्या आता है 1. बराबर.
1. यस सर.
2⁻1 का 2,
यस सर.
2⁻2 का 4, 2⁻3 का 8, 2⁻4 का 16, 2�5 का 32, 2⁻6 का 64 एंड सो ऑन एंड सो
सर
फोर्थ.
क्लियर है, क्लियर है. अब
बराबर.
समझ गया मतलब. हाँ ओके सर.
ये चार मैंने यहाँ पे कॉपी किया, और भी आगे लिख सकता हूँ.
ओके सर.
राइट. उसके बाद में फिल इन द ब्लैंक्स ही किया है हमने, कुछ नहीं.
ओके सर.
वेरी गुड.
और सर वन मोर डाउट है सर.
हाँ.
सर ये हेक्साडेसिमल रिप्रेजेंट ऑफ 1110, इसको मतलब हेक्साडेसिमल में रिप्रेजेंट करना है तो इसका आंसर मतलब 15 हो रहा है, तो 15 का सर.
ए ए ए 15 का रहेगा तो ए करना पड़ेगा अपने को. ये हमने किया भी था. इफ यू सी, एक लास्ट में किसी ने प्रॉब्लम रेस किया था. देखो यहाँ पे देखो, जब मैंने इसको 15 आया था तो 15 ए नहीं, सॉरी एफ ना, 15 का एफ, ए नहीं एफ, 15 का
तो
एफ.
सर मुझे ये मतलब आज क्विज था, तो क्विज में पूछा गया था तो मतलब उसमें एफ का कोई ऑप्शन ही नहीं था. उसमें था मतलब ई का ऑप्शन था, तो ई राइट आंसर दिखा रहा था.
15 आया तो एफ
सर
है ना.
इसका मैं पूरा क्वेश्चन बोलता हूँ सर. द इनपुट हेक्साडेसिमल रिप्रेजेंट ऑफ 1110 इज डैश करके था.
1110, ट्रिपल वन
यस सर.
जीरो ऑफ हेक्साडेसिमल ना.
यस सर.
हाँ, तो ये बाइनरी में था क्या.
1110. यस सर, बाइनरी में है.
हाँ, बाइनरी टू हेक्साडेसिमल है ना वो. सो बाइनरी टू हेक्साडेसिमल करने के लिए तुमको अलग से प्रोसीजर लगाना पड़ेगा ना. बाइनरी नंबर है, उसको सबसे पहले तुमको कन्वर्ट करना पड़ेगा डेसिमल में, एंड डेसिमल टू हेक्साडेसिमल करो तुम. तो देखो, अगर एक डेसिमल नंबर है उसको हेक्साडेसिमल में कन्वर्ट करने के लिए 16 से डिवाइड करना है. तो अगर तुम्हारा बाइनरी है, बाइनरी को तुम डेसिमल में कैसे कन्वर्ट करोगे. सबसे पहले तुम्हारा बाइनरी नंबर बताओ, कौन सा बताया था तुमने.
1110.
ओके, 1110. इसको कन्वर्ट करेंगे तो ये अपना 8421 कोड. तो ये रहेगा 2, सॉरी ये रहेगा 1842. सो इसका इक्विवेलेंट क्या आता है डेसिमल में. 8, 9, 10, 11, 12, 13, 14. बराबर.
यस सर.
सो दिस इज बाइनरी. अब इस 14 को मुझे कन्वर्ट करना है हेक्साडेसिमल में। तो 14 का हेक्साडेसिमल क्या आता है? 9 के बाद 10 की जगह ए आता है,
ये आता है।
11 की जगह बी आता है, 12 की जगह सी आता है, 13 की जगह डी आता है, तो 14 की जगह ई ही आएगा ना।
यस सर।
तो बराबर दिया था उन्होंने।
ओके सर।
राइट, ले लो स्क्रीनशॉट ले लो ताकि कंफ्यूजन ना रहे।
ठीक है सर।
ओके
ओके सर।
ओके, चलो now I'll share the material with all of you.
थैंक यू सर।
Most welcome. Share, export, lecture 2. शेयर कर रहा हूँ मटेरियल। हाँ, मैंने गलती से बोल दिया था। Where is that gone? लेक्चर। हाँ, क्या लिखा है? राहुल राज ने, सर प्लीज मॉर्निंग 4 AM निकलना है सर, ईसीआर जोन नहीं तो लग जाएगी। ईसीआर जोन क्या होता है? मेरी, तुमको 4 o'clock निकलना है। आई वॉन्ट टू लीव टुमारो मॉर्निंग एट 5:30 आफ्टर यू। 5:30 in the sense 5:30 I have to get up, go for my exercise, come back, make my kid ready for school, and 7 o'clock I have to start my car. East Central Railway, okay. सुबह सुबह रेलवे की पटरी पे क्या काम है? सुबह सुबह लोग रेलवे की पटरी पे क्यों जाते हैं? ओके चलो, जस्ट किडिंग। I do normal jogging and little bit physical exercises. That's it. A government employee. तुमने अभी तो बोला तुम बिजनेस करते हो। ओके, गुड, 2 in 1। चलो नाइस। सो दैट्स इट फॉर द डे। मॉम के नाम पे है, हाँ, यस यस यस, यू टोल्ड इट राइट। सो SK Enterprise is very smart. Mommy's name business plus he is doing job and plus what not he is earning money, right? You learn from him. पैसों की दुकान है, पैसों की, पार्ट्स तो नाम के लिए है। चलो, बाय एवरीवन, थैंक यू गाइस, थैंक यू, बाय बाय, गुड डे, गुड नाइट, मिनी बिल गेट्स। यस, चलो आई एंड द क्लास, लीव करता हूँ। थैंक यू ऑल, बाय बाय, सी यू, गुड नाइट, गुड नाइट एवरीवन, गुड नाइट, गुड नाइट, सी यू, गुड नाइट गाइस, गुड नाइट, गुड नाइट, थैंक यू वेरी मच, सी यू ऑन ट्यूसडे नाउ, राइट? चलो बाय बाय, गुड नाइट, गुड नाइट, थम्स अप। मैं भी एक दो थम्स अप दे देता आप लोगों को, राइट? चलो, माय थम्स अप आल्सो वेरी गुड। चलो, so that's it for the day. To end the class, good night everyone, everything is with you, material and all shared. We will meet now on Tuesday, right? 9 p.m. to 11 p.m. Bye.